Now the next topic, that is power. Now first the definition of power. Power is defined as the time rate at which the work is done. Or we can say power is defined as the time rate at which energy is transferred. Or power is defined as work done per unit time. Suppose delta W is the work done in time interval of delta T. Then we can write the average power, that is delta W by delta T. So here if we take limit delta T tends to 0, then we will get the instantaneous power at time T. That is P equal to limit delta T tends to 0 delta W by delta T. So we can write that is P equal to dW by dt. So this one is the new physical quantity which we define here. Because in physics in so many cases we observe this thing, the work done is not important, but in some cases at which rate the work is done, that is more important with work done. Therefore, we have to define this physical quantity and we have to understand how to calculate it. Suppose the work is done at the constant rate, then simply you can write P, that is W by T. Now, we know this thing, work done W, that is equal to F dot dr. So, if we replace this W, that is F dot dr, then we can write dr by dt, that is equal to V. So power P, that is F dot V. So we can write another equation of power P, that is F dot V. Okay. So here unit of power. So unit of work done, that is joule upon time. So unit, that is joule per second, and on behalf of the name of scientist James Watt, this unit that is known as watt also, and its dimensional formula, that is M1L2 T minus 3. Another unit of power, that is named as horsepower, and 1 horsepower 1 HP, that is 746 watt. Clear? Now see here, work done that can be represented as the product of power and time also. So another unit of work, that is known as kilowatt hour. How we define this kilowatt hour? If the work done at the rate of 1 kilowatt for 1 hour, then it is known as 1 kilowatt hour. Okay. Now see here, the electrical energy consumed in our home, in our day-to-day life, that is represented by this particular unit, 1 kilowatt hour. And 1 kilowatt hour, that is known as 1 unit. When we see our electric bill, then in that it is written this much number of units are consumed. That 1 unit, that is 1 kilowatt hour. 1 kilowatt hour means how much energy is consumed. See, 1 unit, that is 1 kilowatt hour, kWh. Here be careful. This one is the unit of work done, not of power. Okay. So 1 kilowatt, 1 kilo, so that is 10 raised to 3 watt. Hour, so that is 3600 second. Now watt, that is joule per second. So 10 raised to 3 watt, that is joule per second into 3600 second. Second cancel. So this is 3.6 into 10 raised to 6 joule. So 1 unit electrical energy is consumed. It implies that 3.6 into 10 raised to 6 joule energy is consumed. See here, suppose we think about the bulb, which one is in your house, right? And suppose that particular bulb that is of 100 watt, right? So if your bulb that is of 100 watt, it implies that if this rating is given to you on the bulb, so if you switch on the bulb, then we can say it will consume 100 joule electrical energy per second. So if in 1 second it consumes 100 joule energy, then in 1 hour how much energy will be consumed? So we can write 100 into 3600, that is 3.6 into 10 raised to 5 joule. This much energy will be consumed in 1 hour. Now suppose we continue this bulb glow for 10 hours, right? Then we can say 3.6 into 10 raised to 5 into 10. So this is 3.6 into 10 raised to 6 joule. It implies that if 100 watt bulb is switched on for 10 hours continuously, then the electrical energy consumed, that will be equal to 1 kilowatt hour, means 3.6 into 10 raised to 6 joule. So that is equal to 1 unit. Means now your light bill that will be increased by 1 unit. Suppose your supplier charge you rupees 10 per unit, it implies that now your electric bill that will be increased by 10 rupees. Clear? So this type of calculations that should be in your mind.